Okay, so today we're talking about the Data Center Alliance Thermal Management Special Interest Group, of which you are the chair. So I guess the obvious place to start would be just a high-level view of what it is and what what you may already have achieved and what you're hoping to achieve.
Yeah, I mean, I think we all know that thermal management is a really, really important part of data centers. All digital infrastructure, all electronics have this habit of converting electricity into heat, but probably in an annoying way. But we have to manage that heat, and of course, there's so many ways of managing the heat. About the way that you set up the white space, about what media you're using, what fluid, whether you're using air or liquid. So really, why it's got thermal management is because it is such a big part of it. That's why it's got the title. And what we want to try and do is mainly try and cover all of these technologies, discuss all of these technologies, not duplicate all of the guidelines and the principles that are out there, but to have an important dialogue about the recent trends, important developments within the sphere, and try and set up some good signposting for all of the people that join the group and participate in the group. And we can do that in various different ways. Maybe we can produce some kind of a high-level best practice document. We've discussed this is a possibility. I mean, we haven't met that often yet. We're starting to get warmed up. I think the heat is coming in. Yeah, so, and maybe to run these kind of 30-minute seminars. So, where we get experts from different fields, whether it's some of the people that are really invested in liquid cooling, or those that are using direct fresh air, or whether it's the different possibilities with chillers, because chillers these days you still have called this free cooling capability, but you also use refrigerants, and of course, this is where it links to other sustainability groups in terms of the energy efficiency of the way we remove the heat, but also are we doing it in a sustainable way? So I can see this special interest group sort of overlapping or intersecting both sustainability and energy efficiency in quite a big way. But I mean, we're still formulating, what the scope is, and I can talk a little bit about that later on. What we've sort of thought our thoughts on scope for the special interest group, but primarily, it's all focused around the technology and the ways in which data centers are managed thermally, or not just data centers. I think maybe with 5G and edge, this is kind of communication. I think the merging of the pure IT and the C that goes into ICT and communication part is now more evident than ever. It's very difficult to say that that's communication and that's data center. Yeah.
No, that's cool. You've referenced liquid cooling a couple of times, as well as the more traditional ways. I guess that's an obvious area. I mean, as anyone who works at data centers IT knows, it's not actually new. I can't remember if IBM or whoever was using it back in the 60s or 70s, but I guess the renewed impetus is noticeable at the moment, to do with, I guess, mainly around high performance computing. So is liquid cooling a particular area of focus? One tends to think, as I say, of air cooling as more traditional, and therefore maybe things that aren't happening exciting, but you may be able to tell me different. And to get to, I guess, to the point of the question, is hybrid cooling, we have hybrid clouds, we have hybrid data center, hybrid virtually everything. Is that where we're arriving at, or will arrive at in the future?
Yeah, I mean, I think it's a very natural question for thermal management, isn't it, Ian? What is the status in terms of liquid cooling? Because it's true that there are a lot of benefits you get from using liquid cooling as part of the thermal management, but it's not for every single application. So I think we've been saying this a long time, Phil, haven't we? That liquid cooling is coming. Has it arrived? And I think one indication of that it has arrived is when some of the bigger enterprises take it a bit more seriously. So I think when you start seeing the hyperscalers using liquid cooling, and when you look at the roadmap for the semiconductors, we can see these heat fluxes have been going up a lot, so it's becoming more challenging to manage the thermal aspects of the IT infrastructure just with air. But that, I think when I came to this, I didn't, I wanted to explain to the DCA that I don't think we should say this is focused on liquid cooling or air cooling, but more of it's an engineering problem, because not all solutions are amenable to liquid cooling and not all solutions are amenable to air cooling. So, you talk about high performance computing, you talk about some of the more recent developments in high performance computing, which we'll probably talk about a little bit later on. Well, applications that are data driven, heavily data driven, like machine learning or this word that we sometimes use called artificial intelligence, these do require a lot of power from the actual compute infrastructure. So, and that power is very dense in a lot of situations, and so cooling it with using a liquid is obviously the way to go forward. So the group says that in scope is all aspects of thermal management, from the chip all the way to the point where it's either rejected or it's utilized later on. Because we'll probably discuss this a bit later on as well, that heat has some value in this, particularly in this decade of sustainability that we're focusing very heavily. It's very topical right now with the COP26 that's going on in the background. That we don't preclude the different solutions, because they do have their values, particularly depending on geography, which we'll also talk about, I'm sure. But hybrids, it's a good point. A data center is not going to say, I've got this data center which is air cooling. Tomorrow it's going to be all liquid cooling. That's not going to happen. So you're going to find that sections of the data center are going to require liquid. And to be honest, going into data centers which are using air cooling, you find that some of them do have chilled water under the floor, because they're going to computer room air handling units that are not at the walls, they're in the center of the data center, or they're going to in-row coolers, which require chilled water, or for the more dense applications, they're going to rear door cooling. And of course, when you bring water into the whites, or chilled water into the white space, the question is that really liquid? That's not what some people would call liquid cooling, but it is bringing liquids closer to the heat source. So there's a bit of a fuzziness around that, and having liquid under the floor in your data center is probably going to data centers are going to have to provision themselves to say this white space needs to be able to manage air cooling and liquid cooling at the same time. So hybrid is clearly going to be on the radar, and is in scope for discussion now with the thermal management special interest group.
And I'm wondering, I mean, you referenced the hyperscalers there, and one tends to think they build shiny new facilities with all the latest technology, including maybe liquid cooling more than others, as you said. But we clearly have a massive, the vast majority of data centers are, if not ancient, they are older. And I guess the thermal management challenges and maybe even, what's practical as opposed to, is it time to shut down that data center because it's kind of beyond hope. So I guess what I'm saying is thermal management is a completely different topic when you're looking at legacy data centers, as opposed to, you've got a nice brand new greenfield and you can build the state-of-the-art data center. Is that right?
Yeah, I think that's true. I mean, if a legacy data center has, for example, a raised floor, I guess you're in the position, depending on how much space you have, or whether you can get a chilled water loop in there or not. So, because I mean, I think once you have chilled water to the white space, and you've got a raised floor, it's only a little bit of extra work you need to do to get water to the cabinet, to the rack. But I think that there are different problems with legacy data centers, and I think I was having this discussion with people, people today, what we've done as a research institute, RISE, which is where I work myself, that's my day job, as it were. But variable speed fans, variable speed pumps, variable speed compressors, actually slowing things down, to be more, you can, a simple solution, if you've got some old legacy equipment, maybe just to switch out some of the drives, some of the fans, and I've seen this being done, and it's a low-hanging fruits approach to thermal management, because you still, if your IT, if your rack density or the heat fluxes you're getting from the IT you have in the rack, which may be 3 or 4 years old, say, but you still, the question here is what is the longevity of servers today compared to what it was 10 years ago? I think because of the sustainability aspects, because of the materials and the energy aspects that are talked about in sustainability special interest group, for example, they have a longer lifespan. So, don't throw away the air cooling capability, improve it, and there are good ways of improving it. And I think maybe this thermal management special interest group, it's not about building brand new sites. It is about reusing buildings. It's about using existing estate, and it's about making. And this is where it overlaps with energy efficiency again, because it's clear that if you have variable speed fans, you reduce the speed of the RPM of your fans, you reduce your energy consumption, so your cooling infrastructure becomes more efficient. So, I think that's all on the cards in this thermal management. I want to make sure that people out there who are going to join this group, that they understand that we're not fixated on liquid cooling. I think it's important that it's an engineering problem. It's a mechanical engineering problem, thermal management, and there are multiple solutions, and as I've said earlier on, not all solutions fit all problems. So.
Yeah, and in terms of the sort of the overall data center environment, I mean, you obviously got the facility, then you've got the IT load, and the data center industry, I won't say it's obsessed, but I guess rightly, the fabric is what it looks at. But a lot of data centers would claim to have a PUE, which is the metric, for energy efficiency. I guess that everyone uses. That they would claim to have a very good PUE, near this one. But the one is the IT load. So the question would be, what role, if any, does the data center industry have in influencing, collaborating with, particularly the IT hardware folks, with trying to, everyone takes the one as a given. Or I guess what I'm saying is, can we reduce the one to, 0.5 or whatever?
Yeah, or can we make the one a smaller one? Yeah, basically.
Yeah.
Yes, in a sense. It's all about energy consumption, isn't it, at the end of the day? Because and I've had this, I think, again, from the special interest group, I mean, I think when you introduce, because there are people that are coming from the liquid cooling domain, and I think once you start talking about liquids invading the IT space, you're actually starting to talk about the one, really, because it's how, I know, I mean, this is the strange thing about the PU, the power usage effectiveness, is that is the fact that the fans, the cooling elements of the servers in the air-cooled solution are considered as part of the one, the IT, and people have been trying to redefine this metric to say, well, that's part of the cooling infrastructure, although it's inside the server. And then, of course, you take it out of the server and you put it in, it reduces the denominator and your PUE goes up. And it's a kind of a perverse incentive. So you always want to include as much local cooling infrastructure, local to the IT equipment, in that denominator of the PUE. But I don't think the PUE should drive this anymore. I think it's at its day. It's been great at providing insight to ways of making the infrastructure, the envelope around the IT space, run better, be more efficient. It's not an efficiency metric, and I think we will always come up against the PUE in this group, because most of the suppliers of cooling equipment to data centers are always talking. They either talk about their mechanical PUE or their partial PUE, because they want, that's a kind of a selling point, isn't it, to the industry that's going to absorb this kind of infrastructure. So, yeah, I think at the end of the day, I think with liquid cooling, when you're getting closer to the heat sources, it kind of fudges, it grays this area out a bit more. And the fact that air cooling equipment has fans in them, whether the metric should be reconsidered to say not including the fans, because that conversely has the wrong effect. But I think we should be using metrics which are more proper efficiency metrics, which is saying, the data center are producing these digital services, and it's how do you measure those digital services in some way, quantity or volume or whatever it is, divided by what you have to pay for, which is the kilowatt hour. That's a proper, an efficiency metric for a car is, how many kilometers can I drive on my kilowatt hours that I consume? The further I can go with the car on less kilowatt hours, the more efficient I am. And that's another interesting thing about data centers, is that all these, the car, when you buy a car, it's about the speed at which you drive it at. Because if you drive it at the sweet spot, the point at which the engine is running it's purring, as it were, then you're not going to consume so much energy in doing that journey. But that journey might take you longer. Unlike the guy who's put his pedal to the metal, I want to get there as fast as I possibly can, will consume more energy. But same thing about IT as well. I think it's the way that the IT is operated is key as well. Because, do you always need to run IT at peak performance? And you find if you look at some of the branded servers, you go into their BIOS, and there are performance modes, modes of operation where it will run the processor at full pelt. It will have the fans operating at high speed to draw the air through as fast as possible. And that's not ever considered, how you operate the IT, as well as this aspect of the division between, where do you draw the line between the cooling? Because the cooling doesn't just stop at the front of the server. The cooling also infiltrates the server as well. It's a tricky problem.
Yeah. So I think I'm understanding that you're saying that PUE is basically no longer fit for purpose, although it's been useful as a basic sort of way of understanding how well a data center might be performing. And you've very well explained how complicated it might be to come up with an alternative. Can you contemplate anything, whether it's the group does it or the industry more widely? I suppose what I'm saying is I'm surprised PUE has been around a long time. Virtually everyone you talk to says it is used and abused, therefore it probably is time for something different, but no one seems to have come up with a magic formula for a new standard. And is that,
I think there's two things. There's two things in its favor. One is its simplicity. And of course, if it's a simple metric, it's the metric of choice, because simplicity rules the day in that sense. Particularly if you're talking to legislators or government or whoever you're talking to, you want to keep it simple. The other thing is that data, when you talk about data center, is always about I guess we're talking about the facility a lot of the time. So it's about the envelope around the IT. The IT is dealt with by the guys who come around with their laptop in their hand, or they're checking the servers are operating properly. What services have I got on these different servers? But I think the complexity of data centers as a whole, with the IT space and the infrastructure around it, treating it as a complete engineered system, is the fact that with the IT, the services that it's providing, there's no way of actually measuring that in some easy way, because you can try these proxies that I guess, and maybe this is something we will discuss in the special interest group, but I think it does sort of come out of scope a little bit, because, you know, how do you, if you're talking about, particularly in this era of sustainability, I mean, sustainability is on everybody's mind. It's stamped on some people's foreheads, you know. So it's, you know, we're in this zone now where we're trying to be more sustainable. But so then it begs the question, well, you've got a server which is really efficient server from the point of view of checking how it works in, say, SPEC, the Standard Performance Evaluation Corporation. It's a server that does, you know, it's pretty power proportional. As you increase the workload, it consumes proportionally a bit more power. As you say, you double the workload, you double the power consumption, for example. But what is it doing? If it's serving, you know, banal social media stuff, or it's working out the formula for some bespoke medicine for an individual, you know, how do you quantify that in a sensible way as the output from the data center? Because we're always trying to talk about efficiency. It's, you know, the true efficiency is what you get from the data center divided by what you have to pay for, you know. And I think, you know, I don't know what the best metric is, because there are so many metrics now. I mean, there's this whole suite of 9 metrics that are ISO for, you know, the 3134 metrics, which are PUE is one of them. But you know, I think, and I've seen academics try to say, oh, well, we need to come up with a metric that weights these different other metrics, you know. So the PUE is a 50% value, the CUE, the carbon usage effectiveness, is this, and the water usage effectiveness, and the renewable energy factor is this much. And we mash all this together and come up with a magic number. But what are these parameters? What are these weightings? You know, how should that be weighted? You know, I don't know the answer. And I think that the special interest group, will probably debate this a couple of times, but I don't think we'll ever come up, as an interest group, come up with a sensible answer. Apparently, there are people out there who are working on new metrics, and I have my ear to the ground, my eyes wide open to what comes out of that. But the best we can do is, you know, be the most energy efficient we possibly can at removing the heat. We accept the heat is generated by the IT equipment or the ICT equipment, and we need to move it away from it. And it needs to be moved somewhere. It's heat transfer. Some people like to use the word heat transfer, and others call it cooling. But heat transfer, cooling is an empty word. Anybody who listens to this, that they will know who I'm referring to, because I've had this conversation with people about this. So it's about moving the heat somewhere else. You
know? I guess on that sort of moving the heat somewhere else, I'm thinking climate and geography are obviously relevant as well. It's no coincidence, I guess, that Iceland, with all its renewable resources and, you know, climate there, and the Nordics where you're based, is it too simplistic to suggest? And I know there are critical applications where milliseconds mean the difference between, you know, making or losing billions in shared trades or whatever. So you have to have a data center pretty much adjacent to the application. But I guess for the vast majority of us, you know, few milliseconds here or there really doesn't make a difference to our lives. So could you foresee a time where, you know, data centers move north and, you know, very much, you know, very further south, because it makes a lot of sense from a thermal management point of view? You know, nature is doing much of the work rather than, you know, the M&E.
Yeah, I think, I mean, that's an interesting point, and I think that's something that, yeah, we know that climate has a big effect on the cooling technologies you use and the way that you can cool data centers. And you know, I think, you know, moving to the Nordics, or to Iceland, I guess Iceland actually sometimes is referred to as the Nordics as well, isn't it? Is that primarily because because of the greener credentials that these organizations can have by using renewable energy. More so, and it just as a consequence of the fact that you're far away from large urban areas, but you've also got this and you're in northern climates. You've got access to cold air, most of the year round. So, I mean, I think it's, and again, the special interest group, I think would, I think we will discuss this aspect because not only we know that digital infrastructure is needed everywhere. I don't think you can ever get away from that. And I think, because, if the aspirations, like I think is it Amazon once said recently as an aspiration for the infrastructure is that we want to have sub 10 milliseconds latency to everyone on the planet. And you can't do that if all your data centers are up close to the Arctic Circle or down near Antarctica. It's impossible. Yeah. And of course, you need the infrastructure. You need the stepping points to get there anyway. So you might as well bring the infrastructure closer to the end user. But then that's where you get some interesting discussions, because it's weighing up the possibility of doing something with that heat versus with just using the local environment. Because whenever we reject heat into the environment, whether it's you get whether it's done by air or whatever, or you rejecting it into the atmosphere or into the sea or into the ground, whatever, other ways of rejecting the heat, it's still warming up the environment. You still it's called this anthropic heat flux from the fact that mankind is generating a lot of heat and all the aspects is doing so. But I think is it I don't know. I mean, I think there's going to be a mixture of things. I think if we need all that batch processing going on behind the scenes for improving AI models, machine learning models, all that data processing that's going to make our lives more enjoyable and better. Should that be done on renewable energy in a cold climate? And I think that debate is a little bit political as well, because you have the issue of sovereignty, don't you, of data as well, which is becoming more and more an issue today than it was in the past. So, where does the data reside? But I think first and foremost is these corporations are taking advantage of the renewable energy sources so that when the likes of Greenpeace come along and say, "Oh, good guys, you're using renewable energy, yeah, that's fine. You're not burning coal." But to quote some people that you probably know as well, why should data centers be burning renewable energy sources? Why not other? Why shouldn't schools be all running off renewable energy, or hospitals, or any other infrastructure that's important, as important, if you like? But I think the special interest group this is a good one to when we get a full house, it's a good one to have a good discussion around it. Be interesting to see what people's views are on this, yeah. Because I think it's opinion. It's all about opinions, because who has a good view of the future, today?
Yeah, and you mentioned I mean, most people call it waste heat, but perhaps that's not the right description of it, because as you've alluded to it, it has a potential use, can be repurposed, if you like. So again, I suppose back to my legacy, everyone seems to suggest that it's very difficult. If you've already got a data center somewhere and there's nothing nearby that can use that heat, then it's pretty much a waste of time trying to repurpose any heat generated in that data center. Whereas again, if you build a data center next door to a school or a factory or an office block, you've got the opportunity, because that basically, I guess, in simple terms, the heat doesn't travel that far very efficiently. So I guess the question is, after all that, what is the potential for waste heat reuse, bearing in mind we have vast amounts of legacy data centers, as opposed to the opportunity to factor it in when you build a new facility?
Yeah, and that's I mean, this is where it comes to the scope of the special interest group, and I think we in our recent meeting we have talked about the scope, and thermal management is about is focused on the IT. The IT's got to run at a nice temperature, so you can get this accumulation of heat, and you need to remove it. So there are ways where different ways you can move that heat away, and we've talked about that earlier on in the discussion. We think waste heat should be in scope with this, because I think again, this is an interesting aspect of liquid cooling, and people may disagree with me on this, but I mean, as we've discussed this in the special interest group, that liquid cooling doesn't really improve your, if you like, your envelope efficiency that much. You still have to use pumps instead of fans. You still have to use insulating material if you don't want the heat to accumulate in the white space. You've got to be very careful the way you do it. So in that sense, you don't really get the gains of liquid cooling, liquids over air. But what you do get is you get elevated temperatures. So, okay, the air cooling scenario would be working at a certain temperature, whereas liquid cooling can raise that temperature a lot. Maybe, the energy costs of running it is still approximately the same, but you're at a higher temperature. And it's at that point you have the two options. Again, it links back to geography. You have the option of rejecting the heat to the environment in hotter climates without using chillers. You could use dry coolers because you're at an elevated temperature and you can get rid of the heat. If it's coming out of the data center at 45, 50 degrees and outside is 35 degrees, you can reject that heat. But the converse of that is in colder areas where you've got you could reuse that heat, couldn't you? You could try to repurpose that heat, and I guess the projects that I've seen, and there are a lot of them are in the Nordics again, is where the energy provider is involved. So, okay, we're going to provide you the electricity, but we also provide district heating to our urban areas. So we'll bring in the heat pumps. We'll look after the heat pumps. You just connect your water loop, your water loop up from your data center to our heat pumps, and we'll upgrade it and put it into the district heating system. Because district heating you need to run district heating in the Nordics. You need to run it all year round. Okay, the energy consumption in summer is much lower, but you still consume it. So you're in the position where you could just vent it. If you can't consume it, any excess you can vent. The problem we have is what you rightly say, is that there's a lot of infrastructure that's a long way from anything that could make use of the heat. So we need to, if there is space next to that legacy data center that is saying, yes, I want to try and get into a situation where I use the heat, it's a tricky one because maybe an energy provider, and the energy provider is not involved. So who's going to look after the heat pumps if you need it? But if you are using, say, just air, for example, if you've got an air-to-air heat exchanger, so you're exchanging heat with the data center in an air loop, you're not going to be able to consume that heat all year round. So, and how do you get rid of the heat in the summer? You need extra infrastructure. So I think, waste heat recovery, has to be done the right way. And if it can't be done, I think the next best thing is how can you operate with heat rejection that's more efficient, and could you look at alternative ways of using the heat? Because I think the lower grade heat, there's the possibility of using it for all kinds of things, sequestration of carbon dioxide, or aquaponics, or and there's some neat examples of where people have been using heat from data centers for fish farming, for example. So there's a lot of different things that could happen. But we data centers run all year round, and we do have these seasons that don't really map very well onto onto it, and therefore we don't want to install this extra infrastructure. Yeah. So I think we've got heat, and I think waste heat recovery is becoming more and more prominent from any new infrastructure we build, and particularly if we start building infrastructure, smaller infrastructure in urban areas. Why not have small heat networks that where you put hospitals, hotels, laundries, whatever, on those heat networks, because they will always have a demand for heat all year round. So it's a bit of joined up thinking, but and the group needs to, whether we talk about whether legislation should be involved in this. I'm sure the sustainability group will have touched upon this as well, because will the legislators come by and say, no, you can't build a data center here? Well, you can, only if the PUE is below 1.1 and you reuse the heat, say, and we can see that's going to happen at some point, and that's why there needs to be the legislator. You need legislation you need to have good dialogue with the legislator, and the legislator, I think, needs to understand the problems. And I think that's where these kind of special interest groups, producing the signposting, all that kind of information could be useful because it's the industry itself, not saying we can regulate ourselves, but these are the pain points, these are the issues that need to be factored into any legislation.
People who watch some of the other videos I do will be fed up with me using this statistic, but I think 80% of all data is going to be generated at the edge, however you define that edge. I think I can't remember if it's IDC or Ghana, and I think the date's 2025 or something like that. So I'm just wondering if the edge is going to explode as predicted, or even anywhere near. Is there an opportunity here for as you say, these smaller local data centers to be sort of networked, or to provide that kind of environment? So as the older legacy data centers maybe are mothballed because we need less large central facilities and much more smaller. Do the two, I suppose what I'm saying is, does the edge and waste heat reuse, is that a happy marriage, or are there sort of obstacles to making that happen?
Yeah, I think, I guess who owns the edge, who is going to manage the edge? I think that's something that's a bit of a gray area, because if the edge is heavily interwoven with mobile data networks that are now next generation mobile data networks, so and who's going to own that? And I mean, I think, how are we going to fund this is one of my big, and I think a lot of people will be talking about this. And the definition of edge is not that well defined. I think everybody's got a different definition. But I mean, let's take it on the basis that it is infrastructure that you need closer to the end user, and if it's significant infrastructure, if it's in the megawatts, or a megawatt, then it would make sense to insist that if you're going to build that kind of infrastructure, that A, the heat is reused, and B, you use systems that that have low noise. So maybe this again will provide the impetus for liquid cooling to be part of the mix, so that you're not actually running any fans. You're just running pumps, which usually are quieter than fans. But I think this is again the crystal ball thing. What will happen? I think will it come down to the question of economics? And will we start asking the questions, do we really need to be creating so much data? I mean, will it focus on the source of the problem? We have all this data generation from sensors that we have, IoT networks, and all kinds of self-driving cars, as everybody talks about. The people talk about how factories and hospitals and airports are going to be generating gigabytes of data, daily. But for what purpose? At some point, I think we're going to have to ask ourselves the question, yeah, and this is a different topic completely. Should we be doing this? I think it's kind of a bit like it's how I see things like using machine learning for operating data centers. When it costs you more energy to find to operate the data center using machine learning algorithms, then you're saving. Then why not just go back to basics and do it the way that it was done in the past? Yeah, I think that's kind of a very simplistic view, but it's an interest. It becomes an interesting discussion point at a dinner table, for example. Should we be doing this? Yeah.
No, you're right. Funny enough, in a conversation the other day, I used the cliche "data is the new oil," and then I suddenly realised that, bearing in mind COP26 is going on, comparing data to oil is probably not a great idea. But maybe it is, in the sense that data is the new oil. It's the new polluter, and as to your point, you need to start asking whether someone needs to take 100 photos of their dog every single day, as opposed to one a month and stuff like that. It sounds obviously an infringement on people's civil liberties and all that kind of debate, but there clearly is an area where you can discuss how much data does any individual actually require.
Yeah, I think that becomes an interesting point. I mean, there are two aspects of using the term oil. First of all, you're going to get this issue of peak oil, which you've come. I think in terms of data, yeah, the concept of peak oil probably easily maps onto that as well, because but the other aspect of it is when you've got oil, when it is the new oil, but we need refineries. We need to refine it. So so maybe we don't need to store so much data. We just need to extract the information that makes things work better, that helps people's lives, that solves the challenges that we face as a species. Maybe that we need to refine that data, and that's different. We need proper algorithms, good algorithms for that. But then you're going to start burning energy in the data center to do those, to run those algorithms.
Yeah, no, it's not any. I mean, my background was in the storage industry, and there was, I think it's the 80-20 rule that 80% of the data is used once and then that's it, but it's kept forever, and 20% is used on multiple occasions.
Yeah.
But everyone was terrified of deleting the 80% just in case the boss,
just in case, yeah,
6 months time said, "Where's that bit of information?" Who was going to tell him that we deleted it? But yeah, but to your algorithm point, I guess that's maybe my final sort of question is the whole AI. You've referenced AI, machine learning, in terms of the demands it makes on the data center, but clearly it also has a role in controlling. And you've made the point that if it uses more energy, then you're saving. But is there a role potentially for AI, machine learning, to help with this thermal management issue, to just to get smarter decision making that maybe humans can't do in a timely fashion or at all? And is that something you folks are looking at? Because clearly AI is a bit outside the, shall we say, the traditional data center skill set.
Yeah, I think that's where we need new blood into the special interest group. There's probably too many old folks that say that are very skeptical about AI, but it's clear that machine learning, we see all the applications of machine learning in different spheres. It does work. It can work, and it could be influential. And I think, and I'm sure that suppliers of, because at the end of the day, from the thermal management, it's a control problem. There's physics involved. Okay, whether you use air, liquid, or what kind of heat exchangers you're using, plate heat exchangers, whatever. There's all different kinds of different. You can pick these off and build your system. But at the end of the day, with all these flow controls, temperature set points, etc., it's a control problem. And I think the suppliers to the industry that is their unique selling point, is their control. So if you look at them, they all have been investing heavily in control systems for the want of a better word, cooling equipment. But this is thermal management. And when you've got complex control problems, what set points do you use? And if you run lots of scenarios and generate lots of data, you have a data-driven model, which is governed by machine learning. Then you can use things like federated learning, so you can transport this to other scenarios, and those, the operational parameters that you hone in on with a machine learning algorithm, makes a lot of sense to do that. But that's you need to invest in the right people that have the right backgrounds in working on these kind of things, because I think somebody who's got machine learning, who has studied machine learning or implemented machine learning algorithms and knows a lot about control and the thermodynamics aspects of that could be in a good position in the future. Yeah, definitely. Yeah.
Okay, we've covered a fair amount of ground. It's been great. And maybe in conclusion, in terms of what the special interest group is going to focus on over the next, I guess during the next year or so, do you have any sort of plans or projects, or is it still sort of just discussing all kind of the topics we've discussed before you arrive at the ones that you want to prioritize?
Yeah, I mean, we've talked about this kind of signposting, and maybe that's going to be through some kind of discussion paper or whatever. I mean, there's just the problem with thermal management is I think it is such a huge topic. I think compared to the other special interest groups, I think we've got something that has a huge myriad of solutions and a range of diversity that makes it quite difficult to do this signposting. And I think maybe not everybody's up to speed on all aspects of thermal management, which is why I thought, when we run these special interest groups, we should have experts from different sectors. People doing in the control space, people in the liquid cooling, different types of liquid cooling scenarios, or people that use, air cooling, but to have a control strategy that's very different to others. We need to all understand this, and I think the group would in this early stage of trying to develop some signposting for whoever needs that signposting for thermal management of data centers, then we should have these kind of expert seminars, so that's what we will try and do. We will try and plan these out. I'll be going around calling on people to see if they'd be willing to share their knowledge or share their experience or expertise with the group, And I think, seeing some of the other special interest groups, how they've operated, it kind of sits well with some of the others as well. I think that's kind of how they've done it, to get the dialogue going. But I guess, when you talk about sustainability, it's a very new topic for a lot of people, whereas thermal management, been doing thermal management since we set fire to a sort of piece of wood many years ago. So how do you maintain that heat? Yeah, how do you keep the fire going? Yeah, in the cave. So yeah, I mean that's yeah. So it's an old topic, like liquid cooling is a very old topic as well. But it still has. We still need to have these discussions to make sure that we all understand the nuances, so that when we talk to each other, when we have the dialogues about what's going to go into the signposting documents, or the best practice, some kind of best practice explanations, or where the pain points are in thermal management, then we need to have those seminars. I think, yeah, that will help us develop the group over the next year.
Okay, well, it's been lovely. I mean, I've really enjoyed chatting to you, and we covered a lot of ground, some great insights. So Jon, thank you very much indeed for your time. Thank you.
Thanks a lot, Phil. Yeah, thank you.